YouTube channel. In this video we will solve problems from CSIR NET June 2023 part C question from the topic linear algebra. In this video we will solve two problems with question ID 704074 and 704075. The first problem, let V be the vector space of real polynomials in one variable with degree less than or equal to 10. T from V to V be the linear map defined by T of P equal to P dash, where P dash denotes the derivative of P. Which of the following statements are correct? So here the mapping T is defined like this: T is from V to V and T of P is equal to P dash. So first we will write the basis for V. So V is a real vector space of real polynomials in one variable with degree less than or equal to 10. So therefore our basis of V is 1 x square x power 10, and here dimension of this vector space V is 11. So it is defined by P of P equal to P dash. So therefore when P is equal to 1, so we get T of 1 equal to, that is d by dx of 1, so this is equal to 0. So this can be written as a linear combination of this one. So 0 can be written as 0 into 1 plus 0 into x plus 0 into x square plus etc. 0 into x power 10. So this forms the first column of our transformation matrix. So let us write the T matrix. So T matrix, so 1x square x power 10, and this one 1x square goes on x power 10. So we will form the matrix. So the first column are the coefficient, first column is the coefficient of this one, so it will be 0 0 0, so everything will be 0. And when P is equal to x, so this implies T of x is d by dx of x, so we will get 1. So therefore this can be written as, so 1 can be written as a linear combination of this basis vectors. So 1 into 1 plus 0 into x plus etc. plus 0 into x power 10. So in the first entry will be 1. So on the rest of the entries, so will be 0. And similarly here, so T of x square, so T of x square is 2x. So therefore, so here it will be 2 0 0, and this one, so it is x power 9. So x power 9, so when we differentiate, so we will get 9 x power 8. So x power 8 and x power 9, and this one is 0. And x power 10, so when you differentiate x power 10, we will get 9 x power 10 x power 9. So therefore, so here it is 0, all these entries are 0. So 0 0 0, and it goes on like this, 0 10 0. So the order of this matrix will be 11 by 11. So in this matrix, so first column and the last row will be 0. So therefore, so when we find determinant of this matrix. So this is equal to 0 since first column is 0. So therefore, we need to check which of the following statements are correct. So this statement is correct. Determinant of t is 0. So now let us find the rank. So the rank, so when we omit the first column and the last row, so we will get a 10 by 10 submatrix. So 10 by 10 submatrix, determinant of this 10 by 10 submatrix is non-zero. So therefore, rank of t is 10. And next we will find trace. So trace is nothing but the sum of the diagonal entries. So sum of the diagonal entries, all the diagonal entries are 0. So 0 plus all the entries are 0. So therefore trace is 0. So therefore the first option is correct and third option is also correct. So next we will check whether all the eigenvalues of t are equal to 0. So here the given matrix, this matrix, the matrix we formed, that is T matrix, is an upper triangular matrix. So for triangular matrix, the eigenvalues are its diagonal entries. So this implies eigenvalues of T are its diagonal entries. So that is eigenvalues are 0, 0, 0. So this is 11 times. So therefore all eigenvalues are 0. So therefore for this problem all the options are correct. It's a part C question. Therefore here all the options are correct. So now let us see the next problem. So this problem is related to the algebraic multiplicity, geometric multiplicity. So given problem, so involves the matrix A, which is a 5 by 5 block diagonal real matrix with the diagonal blocks E1, 0E and E1, 0, 0E, 0, 0, 0E. Which of the following statements are true? So from the diagonal block, so we can see that the eigenvalues of this block. So we rewrite the block once again. So E1, 0E, and the second block is E1, 0, 0E, 0, 0, 0E. So there are two blocks, and so eigenvalues. So again this is a upper triangular matrix. So eigenvalues are its diagonal entries. So here eigenvalues are E, E, and here it is also a diagonal triangular matrix, upper triangular matrix. So eigenvalues are its diagonal entries. So eigenvalues are E, E and E. Therefore, so now we will find the algebraic multiplicity. So here there occurs only one eigenvalue E of multiplicity 5. So here it is 2 times and here it is 3 times. So therefore, so from this algebraic multiplicity of E is 5. So therefore the first option is correct. So next we will see whether A is diagonalizable or not. So to find A is diagonalizable, so we need to check whether A is diagonalizable in each block. So for the first block we will check. So diagonalizable means, so diagonalizable, so this implies algebraic multiplicity of lambda equal to geometric multiplicity of lambda. So this should hold for all lambda. So we will check. So here lambda is equal to E. So let us take the block E1, 0E. now a minus lambda. Okay, so let us take this as a1 and this as a2. So now let us find a1 minus lambda I into x is equal to 0. So here a1 minus lambda I, so lambda is equal to e, so that is a1 minus ei into x equal to 0. So a1 minus e have 0 1 0 0 and x is x1 x2 is equal to 0. So when we solve this, so we will get x2 equal to 0 and x1 is some parameter r. So therefore x1 x2 is r0, so it involves one parameter. So eigenspace is, it involves only one vector, so therefore dimension is 1. So this implies geometric multiplicity is 1. Okay. So in the first block, algebraic multiplicity is 2, whereas algebraic multiplicity is 2. So therefore this implies, from this itself we can conclude that a1 is not diagonalizable. So next, similarly we will do for the block a2. So we will take for a2 lambda equal to e. So now a2 minus lambda I into x equal to 0, we have a2 minus, so lambda is e times x equal to 0. So a2 minus e is, ea is 0 1 0 0 0 0 0 0 0. So x is x1 x2 x3 equal to 0. So here x2 equal to 0 and x1 equal to some parameter s and x3 equal to some parameter t. Therefore x1 solution x1 x2 x3 s0 t. So therefore this is s1 0 0 plus t times 0 0 1. So therefore now the eigenspace corresponding to this eigenvalue lambda equal to 2 for the block a2 is 1 0 0 and 0 0 1. So this implies dimension is 2, that is geometric multiplicity is 2. But what about algebraic multiplicity? Algebraic multiplicity is so multiplicity of roots. So here e occurs 3 times, so algebraic multiplicity equal to 3. So here also geometric multiplicity is not equal to algebraic multiplicity. So this implies a2 is not diagonalizable. So as a whole, so from the conclusion, A is not diagonalizable. So the option A is not diagonalizable, so this is also correct. So next we will check the geometric multiplicity of E in A is 3 or 2. So in the first block A1, geometric multiplicity is 1, and second block A2, geometric multiplicity is 2. So therefore The multiplicity, total geometric multiplicity is 2 plus 1, 3. So this one is wrong. So therefore, for this problem, option A, B, C are correct. So this is a part C question. So if you like the content of this video, kindly like and share with your friends. Also subscribe our channel for more videos. Thank you.